Good morning. So, in the previous class, we talked about what is boiling and what is the difference between boiling and vaporization. And we have seen how boiling initiates, what are the conditions that boiling initiates. And we have seen that, how boiling takes place, uh, depending on the saturation temperature and this surface temperature. Now, let us talk about pool boiling. In this particular um, lecture, we talk about pool boiling. As I told you, boiling can be categorized into two forms. One is pool boiling and the other one is flow boiling. But as far as our syllabus is concerned, more emphasis has been given on pool boiling, okay, which is in fact very important. As I told you, you all know pool boiling. Uh, you know, in the previous class, as we have discussed, that pool boiling, you have a pool of liquid, a stagnant liquid. When you have a stagnant liquid, and inside which if the liquid is undergoing boiling process, then we say that is pool boiling, right? There should not be any flow inside the uh, boiling. I mean, because of natural convection, uh, what happens? The low density fluid, when the bubble grows, what happens? The bubble decharges and it rise up and it vaporizes, right? So this may take place, but the whole bulk of the fluid or liquid, it should not flow. Because of the natural convection, what we call the convection currents may take place inside the liquid, but the whole bulk of the liquid should not flow. Basically, what I mean to say is the entire liquid, inside it there might be the flow because of density differences, but the whole bulk of the fluid should not change, or the whole bulk of the fluid should not flow. So that is an example of, so that is that kind of boiling, we call it as pool boiling. So in pool boiling, you have four boiling regimes. We have four boiling regimes, or we call it as four boiling phases, or four boiling steps that we can observe. It it depends on the excess temperature, depending on excess temperature, delta T excess, the boiling, the pool boiling can be categorized into four regimes. One is, I'll write with another pen. So first one is natural convection boiling, when delta T excess is up to 5 degree Celsius. Next one, nucleate boiling. Nucleate boiling, right? When delta T axis is in between 5 degrees Celsius and 30 degree Celsius. Next one is transition boiling. Transition boiling. When delta T excess is in between 30 degrees Celsius and about 120 degree Celsius. Last one is film boiling. When delta T excess crosses 120 degrees Celsius, or basically I should say if it is beyond 120 degree Celsius. Okay. So these are the four boiling regimes that you can observe, or that we have divided into, okay, based on the excess temperature or based on the physical phenomena that we observe. Okay. Firstly okay, let me explain these boiling regimes using simple uh, pan filled with water. Okay, of course, if the water is boiled, then obviously that is a classic example of pool boiling. Fine. Okay. Okay. So first, let me take a pan. Okay. Inside there is liquid. Okay. So this is my vapor liquid interface. Okay. Now, from here, the heat is being input. So this surface is getting heated up, and that heat of course would be transferred to the liquid. Okay. Now we all know that the temperature inside the temperature of the liquid increases. Say for example, this is water uh, at 1 atmospheric pressure. Okay. Now water at 1 atmospheric pressure, saturation temperature would be 100 degree Celsius. We know water at 1 atmospheric pressure, its saturation temperature is 100 degree Celsius. So until the water inside this kettle it reaches 100 degrees Celsius, the temperature of the liquid goes on increasing. Now, once it reaches saturation temperature 100 degrees Celsius, the liquid temperature further will not increase. You know, because at that particular point, boiling takes place. Okay. Now, let us suppose if the surface temperature is 101 degrees, what is the delta T? Delta T is Ts minus T set. So, 101 minus 100, that is 1 degree Celsius. Now what natural convection says is, I got my T axis, I got my delta T axis as 1 degree Celsius. In this case, if I assume that surface temperature is 101 degrees Celsius and my saturation temperature of course it will not change 100 degrees Celsius. So what happens? Observe very carefully. When the delta T axis is up to 5 degrees Celsius, that means, now, if I consider Ts as 101 degrees, then obviously Tsat is 100 degrees Celsius because I considered water at 1 atmospheric pressure. So delta T would be 1 degree Celsius. If I consider 102 degrees Celsius, delta 2 would be 2 degrees Celsius. If I consider 103 degrees Celsius, delta T would be 3 degrees Celsius. If I consider 104 degrees Celsius, delta T would be 4 degrees Celsius. If I consider 105 degrees Celsius, delta T would be 5 degrees Celsius. So up to until this particular point, so let me write this: natural convection boiling. Okay, so up to until this point, until the delta T is 5 degrees Celsius, until the TS, if it is water at 1 atmospheric pressure, obviously T sat would be 100 degrees Celsius. So if delta T to be 105 delta T to be 5 degrees Celsius, then T surface obviously should be 105 degrees Celsius. Until the delta T reaches 5 degrees Celsius, or if it is in this condition, if saturation temperature is 100 degrees Celsius, then until surface temperature reaches 105 degrees Celsius, boiling will take place, but that boiling we call it as natural convection boiling. Observe very carefully, observe very carefully that this type of boiling, is simply convection. Simply convection. Yes, you'll observe once the surface temperature reaches more than saturation temperature, what happens? Boiling takes place. When surface temperature is greater than saturation temperature, boiling starts. Right? Boiling starts. So what happens? You will see these small bubbles generate, and these bubbles, because of, they will detach from the surface and they will move, but they do not move to the top. Observe very carefully. You can observe if you put a kettle on the stove, and if you fill it with water, and if you observe this, you can observe all this physical phenomena by yourself. What happens? These small bubbles, they will rise, but they will collapse in the fluid itself. They will collapse in the bulk of the fluid itself. They do not reach to the top. So these small bubbles will generate, and they will collapse in the middle of the fluid. They do not reach to the top. So this is like, you will observe this, that if you look this phenomena into a kettle filled with water, then you will see there is some strange motion of fluid inside it, right? So that is natural convection, and it happens until the surface temperature, if it is water, for which the saturation temperature is 100 degrees Celsius, until the surface temperature reaches 105 degrees Celsius, or until the delta T excess reaches 5 degrees Celsius, your natural convection boiling will takes place. Next one is nucleate boiling. Nucleate boiling. Okay. So you will see in nucleate boiling, you will see initially, okay, the same liquid is filled with some water. The kettle is filled with, the pan is filled with some water. So this is your vapor liquid interface. Okay. And inside, because I have considered water, so this is my liquid is water at 1 atmospheric pressure. Okay, this is my surface temperature, and this is Tsat, of course, is 100 degrees Celsius, because it is water at 1 atmospheric pressure. Now, what happens if the delta T is more than 5 degrees Celsius? If the delta T, you have seen here, nucleate boiling, if the delta T is in between 5 degrees Celsius and 30 degrees Celsius, that means until the surface temperature reaches 130 degrees Celsius, then only delta T would be Ts minus Tsat, that is 130 minus 100, that is 30 degrees Celsius. It could be anything in between 105 and 130. Surface temperature could be anything in between. In this case, if the saturation temperature is 100 degrees Celsius, then delta surface temperature would be anything between 105 and 130. And in general, delta T excess should be in between 5 degrees Celsius and 30 degrees Celsius, not below that. If it is below that, we can say that it is simply natural convection. We can say that it is simply natural convection boiling, right? But if it is nucleate boiling, then delta excess temperature should be 5 degrees Celsius to 30 degrees Celsius. Now, in this case, what is the phenomena that is going on is, observe very carefully. Initially, yes, you have already bubbles being generated, and the whole that is simply natural convection. Natural convection boiling is simply natural convection. Okay, there is no big phase change happening, even though yes, the bubbles are being generated and they will collapse in the bulk itself. But here the small isolated bubbles generate, but they will reach to the top, and at this liquid vapor interface they will collapse and they will form vapor. Okay, initially the small bubbles, okay, they we call it as nucleation sites. If you put a small hole in this pan, you will observe the first bubble being generated from there. If it is a smooth pan, and if you put a small hole on the surface of the pan, when you fill it, you fill it with water, and when you heat it, what happens during the boiling process, you will see the first bubble being generated from there. Okay, so it depends on the nucleation sites. Of course, it starts here itself in natural convection boiling, but what happens here is they will reach to the top. That is what I mean to say. These bubbles will reach to the top and they will collapse there, and thereby forming vapor. Okay, and as the temperature goes on increases, as the temperature goes on increases, the delta T increases, as the surface temperature goes on increases, or in other words I should say, as the excess temperature goes on increases from 5 to 30 degrees Celsius, you will see large number of bubbles, very high frequency of bubbles. And if you'll observe all these things in a kitchen, right, you observe that, you can observe this phenomena in your kitchen. That is what is happening when you put water in a kettle and you allow it to boil. You will see more number of bubbles being generated very fastly. Initially very slow, and after the excess temperature is more than 5 degrees Celsius, yes, you will see the bubbles generated and they reach to the top. And as the delta T increases more than 5 degrees Celsius, you will see more frequency bubbles being generated with very high frequency, and they reach to the top and thereby giving the vapor. Okay, now the next one is transition boiling. Transition boiling. So what is happening in transition boiling is, you take it, let us suppose the same pan, and you fill it with water. You fill it with water. Okay, so heat is being generated from here. Okay, so heat is being generated from there, and what happens is, here in this case, as we have seen, if the delta T is in between 30 and 120, that means if you consider this as water at 1 atmosphere, then saturation temperature would be, Tsat would be 100 degree Celsius, and obviously delta S to be, obviously it should be more than, surface temperature should be more than 130 degrees Celsius, because then only delta T could be 30 degrees Celsius. So delta S should be more than 130 degrees Celsius. So delta T excess, which is Ts minus T saturation, it should be up to, it should be in between 30 degrees Celsius and 120 degree Celsius. That means your surface temp, if it is water, if for this condition, if it is water which is having saturation temperature is 100 degrees Celsius, then delta S should be in between 130 degrees Celsius, 130 degrees Celsius, and what is this? 130 degrees Celsius and 220 degrees Celsius. 220 minus 100 is 120. So up to this range, it should be more than 130 degrees Celsius and less than 220 degrees Celsius. Then only delta T excess should be in between 30 and 120 degree Celsius. Okay, is that clear? Now observe very carefully. What happens in this case is, during nucleate boiling, you see large number of bubbles being generated with very high frequency, and they reach to the top and they vaporize, right? But here in this case, what you observe is the bubbles formation will be very large, like this, large vapor bubbles. Okay, they will reach to the top. They will reach to the top and they will, they collapse at the liquid vapor interface and they form into vapor. But initially, the bubble formation, the size of the bubble will be very high. That is what we call vapor blanket, or vapor process. What happens is, the bubble itself is very large. It's not a small bubble, right? The bubble itself is very large, and what happens is, see, what happens is they will form vapors, large vapors here. Okay, so that is the reason. What is happening here, it is being transitioned. So now the the bubble formation itself is very large. The bubble size of the bubble itself is very large, so it is being transitioned. So that is the reason this is called transition boiling. Okay, so now the major portion of the surface is covered with these large bubbles, vapor bubbles. Okay, it's like the major portion is covered with some vapor itself. Okay, so this type of boiling is called transition boiling. Now lastly, we have, what is that we have? Film boiling. Now you see the film boiling, it should, if the delta T is more than 120°C, you take the same example. Let us take the pan which is filled with water. Let us suppose it is filled with water. Okay, and it is water at 1 atmospheric pressure, so obviously T sat should be 100°C. Okay, so the surface is given some heat. Okay, so what it says is, if Ts is more than 220°C, that means if delta T excess, which is Ts minus Tsat, so that is 220 minus 100°C, which is 120°C. If it is greater than 120°C, if delta T excess is greater than 120°C, or for this case where the saturation temperature is 100°C, in this case, if Ts is greater than 220°C, so that delta T would be greater than 100°C. In this case, what happens is, these large vapor bubbles will form a thick blanket, of vapor, Okay, and this kind of boiling is called, again, see, the bubbles, they will reach to the top and they will vaporize. They get vapor, they'll be vaporized. Okay, evaporation takes place at the liquid vapor interface. But what I mean to tell you is, they will form a vapor film. Okay, if the surface temperature is more than 220°C, if it goes on increasing, then what really happens is, you will see a vapor film. And that is the reason, if you put a pan filled with water on the stove, if you leave it for large time, what happens on the surface, you will observe a small layer. That layer is actually because of the vapor. Okay, so this a small blanket of vapor which will be generated because of this large bubbles, large size bubbles. What happens is, all these bubbles, in this case, see, in the previous case, we talked about like this, right? The small vapor bubbles, the large vapor bubbles. But here, all these vapor bubbles collide and they will form a blanket, a thick blanket. And this kind of boiling is called film boiling. Okay. So these are the four regimes that we have in boiling. And let us see, let us see the boiling curve for pool boiling. So all these things put together, boiling curve for pool boiling. Okay, this is very important. Okay, now observe this very carefully. This is very important, very important. Okay, so this is, let us suppose this is A point, this is B point, this is C point, this is D, and this is somewhere here is E. Okay, let us suppose this is 10 cube, this is 10 to the power of 4, this is 10 to the power of 5, this is 10 to the power of 6. Okay, this horizontal axis is actually, this is delta T, this is delta T axis, that is Ts minus T sat. Okay, now if the delta T is in between, if the delta T is in between 1 to 5, this is approximately, not minus 5, this is approximately. Okay, if the delta T is in between 1 to 5 degrees Celsius, then you know that that is natural convection boiling. If it is in between 5 to 30, then we know that it is nucleate boiling. But in nucleate boiling, you see, when the delta T is in between 10 to 30 degrees Celsius, then the bubbles will actually rise to the free surface. Bubble rise to the free surface. I told you nucleate boiling, the bubbles will rise to the top, right? So A to B, what happens is you will see the increase in number of bubble generation. You will see the frequency of bubble generation. But here, when actually from 5 to 30 degree, when delta T is in 5 to 30 degrees Celsius, you will call that as nucleate boiling. But when actually the delta T is in between 10 to 30, you will see more number of, bubbles being rise to the top, so that that will be converted to vapor. But here in when the delta T is in between 5 to 10, you will see the frequency of bubble generation, or the frequency of bubble generation is very, very high. More number of bubbles being generated, but they may not reach to the top. But when in between 10 to 30 degrees Celsius, when delta T is in 10 to 30 degrees Celsius, you will see the bubble rising to the top. And you will see here, this is heat flux. This is heat flux. watt per meter square. Okay, you will see more number of heat, maximum heat flux is in the nucleate boiling itself. No, this is nucleate boiling. Okay, now delta T is in, if the delta T is in between, when the delta T is in between 30 to 120, you will call that as transition boiling. And you know, after 120, you know that it is, after 120 it is film boiling. A blanket of film will be formed. So what happens initially is, here you will not form any, I mean, you will not see hardly any bubble. Even if you see any bubble generation, that you cannot call it as boiling, but you simply call it as convection, normal convection. But 5 to 30, yes, more number of bubbles will be generated. And if it is in 10 to 30, yes, bubble will rise to the top. So that is the nucleate boiling range. And what happens after this range? See, until now, heat flux is actually increasing. The water could able to take more amount of heat from the surface. But what happens after that? There is actually the reverse trend. What I mean to say is, your temperature is, I mean, your heat flux is actually decreasing, even though your delta T or surface temperature is increasing. Delta T increase అవుతుందంటే ఏంటి? Surface saturation temperature cannot change depending on the liquid what you have used. For example, if it is water at 1 atmospheric pressure, it is 100 degrees Celsius, which is fixed. When I say delta T is increasing, then what I mean to say is surface temperature is increasing. Even though surface temperature is increasing, you will see that actually heat flux is decreasing. Why? Because I told you, in transition boiling you will have large vapors, right? So when heat has to flow through the gas, vapor is gas. When heat has to conduct through the gas will have very low thermal conductivity, so it will not conduct that fast into the gas. But heat flux is change, I mean, your amount of heat that is given, your amount of heat that is given at the surface is the same. It is not changing. So what really happens at this point is, your surface temperature keeps on increasing, even though you're not increasing. I mean, you're not actually giving more amount of heat to the water because of these large vapors, gas. The heat conduction through gas is very, very less when compared to any liquid. So your heat, I mean, your heat conduction into the liquid, because at the surface it is conduction. Liquid low, we call it as convection, right? So at the surface, the heat conducted to the liquid is very, very, very low. But Q is not changing. Q is not changing. Q is same. So in order to compensate that Q, your see HA delta T, Ts minus T set. A is not changing. H is not changing. Right? So what happens? Delta T set would be same. So delta Ts would increase. And Ts, if Ts increases, what happens is, this is the maximum heat flux. And after this, your pan surface may melt. Your pan surface may melt. And that is what we call burnout. Okay. So nobody will take that. And at this particular point, you see, at 120 degrees Celsius, what happens is, that is what we call Leidenfrost point. What is that Leidenfrost point is? This is very crazy that you can all observe in your day-to-day life. If you have a pan and it's very heated, and if you put a drop of liquid on it, what happens? The liquid will just dance on the surface, right? The liquid bubble will just dance on the surface and it will vaporize. Okay, so this is the Leidenfrost point. If the surface temperature of the heater, or మనం మాట్లాడుకున్నదైతే pan, so if it is very, very, very high, you will directly reach to this particular point. You will directly reach to this particular point, because you're not gradually increasing the surface temperature. Your surface temperature is already at this particular point, and you are pouring some water in it. So what happens? It will just like a magic, the vapor just the liquid bubble just vaporizes. It will just dance, and it will vaporize. So what is happening? The bubble will actually dance is that, see, that at that particular point there will not be contact between that liquid and the surface, because at high temperatures you will see that, see, on the surface it's get vaporizes, but on the top it may not. So because of this, it will just wobble. You will see like you may think like dancing, but it's not exactly that. It is because of the unbalance. The bubble just it will just wobble to the left or right, and after some point it will vaporize. Okay, so this is the boiling curve, which is very, very important. Okay, thank you so much.